here we have this expression A intersection B complement, the whole complement, union B intersection C. Let's try and simplify it algebraically. Here we have something like X intersection Y, the whole complement, which we can simplify using De Morgan's laws as X complement, A complement, union this Y complement, Y itself is B bar. So B bar bar will be simply B union B intersection C. Okay. Now this expression we are going to simplify using the distributive law. Okay, we are going to just assume that this is some X, and X union B intersection C, union over intersection is X union B intersection X union C. Okay, so we can now write this as A complement union B intersection A complement union B union C. Now by associative law we can take the union of B union B first. B union B is the same as B. So A complement union B intersection A complement union B union C. Okay. Now you can see that A complement union B repeats in both, but how would we simplify this? For this we need a small trick, which is if we had this as A complement union B union null, which is the same as A complement union B, because any set union null is the same set, intersection A complement union B union C, then it's easy to simplify. You can see that A complement union B can be in some sense taken as common union. So this is one set, X union phi intersection X union C. We can apply distributive law, X union phi intersection X union C. Okay, this is X union phi intersection C union, because this is how we would have simplified, X union phi intersection C. So X is A complement union B union phi intersection C. Phi intersection C, null set, intersection any set is simply null. So it's A complement union B union null, which is the same as A complement union B, because any set union null is the same set. Okay, let's try and simplify the same thing using a Venn diagram. Okay, we have A, B and C. Okay, let's see what happens. A intersection B complement, this is A. What is B complement? All the elements. So let's try and shade the elements that we want. Okay, so let's put a so B complement is all the elements not in B. A intersection that, sorry, we can just shade this. This is going to be all the elements in A and in B complement, because you shouldn't include any element in B. Now its complement is going to be, now let's say I use the straight line to specify these regions, all the things that don't have these slanting lines. Remember, the slanting lines are there in this entire region just outside of B. So all these regions will be part of A intersection B complement, the whole complement. Now this thing has union B intersection C. Let's look at B intersection C. This is B intersection C. Now you can see that all the elements in B intersection C are already part of our this region. So we have two regions. One is this straight line, the other is the shaded region. You can see that B intersection C is part of the dashed region, and therefore there is no change. After adding the second component, the operation, we are still left with the same original region. Now what is that original region? Let's see. Everything that is not in this shaded portion. Now what is the shaded portion? Well, we could have simply called the shaded portion as A and the dashed portion as A complement. But the problem is A complement will not include this. But we want to include that. We want to include this region which is part of A and therefore not part of A complement, but we have found in our simplification this is part of the dashed region. So this is the dashed region is simply A complement, all the things not in A, but this extra. This extra is nothing but if you included B, then it will encompass everything. Okay, so this region is simply A complement union B. Well, you could have also written it as A complement union A intersection B, because A intersection B is what is getting added to the A complement. But this is, it looks like this has more variables in the simplification. This looks like a simpler form, and it's very clear that if you did A complement union B, you will get the dashed portion in the shading, and this is exactly what we got in the algebraic simplification also. So the answer is A complement union B.